this is going to be a quick review of a lot of things. We're going to talk about why we factor, what does it mean to solve a polynomial equation to find its roots or its zeros, and how we can graph them. So I'm going to use the examples that I used previously in my garden video. So if you haven't watched that, you might want to go watch it. So we're going to imagine that I have a function that is y equals x plus 2 times x plus 3. And so that's already factored. Well, with that factored, what we're going to do is find the zeros. That means we're going to say, how could we make this y into a 0? In other words, all this needs to be a 0. Well, we know that anything times 0 is 0. So really, I could just say, what if I made this little piece into a 0? If that were a 0, the whole thing would be a 0. Well, also, if this little piece were a 0, the whole thing would be a 0. So if either of these is a 0, then the whole thing is a 0. So what I'm going to do is just take each of these pieces separately and imagine making them equal to 0. So here they are. Some of you might already see this jump out at you or you remember it. If not, you might want to just solve it like an equation. So I could say, okay, how can I get x by itself? Subtract 2 from both sides, and 0 minus 2 is negative 2. I'd rather just look at it and say, I know a negative 2 has to go here, so that negative 2 plus 2 equals 0. Same thing over here. And so I get that if x is negative 2, or if x is negative 3, then this whole thing, in other words, y would be equal to 0. Now, the reason we do that is so we can graph. So I'm going to take you over to my graph here, where I'm showing you this written as an ordered pair. If x is negative 2, then y is 0. If x is negative 3, then y is 0. So I can put those points on my graph. So here come my points, right here, at negative 2 and negative 3. That's negative 2 comma 0, negative 3 comma 0. Now, why would we factor? Why would we want a factored form instead of that multiplied out form? This, again, is from the garden video, so I'm going to speed through this part. But if you've watched that, you know that this is just another way of writing this. So here is my multiplied form, not factored. And since zeros are easy to work with, I'm going to imagine, what if x were 0? If I put in a 0 for x, I've got 0 squared plus 5 times 0 plus 6. Well, 0 squared is 0, and 5, 0 times is 0. So if x is 0, then y is 6. I can also write that as an ordered pair. So here I've got 0, comma 6. That's another point that I can put on my graph. So I'm going to find 0, 1, 2, 3, 4, 5, 6. And I've got enough points to sketch this polynomial. It's a quadratic. If you watch the families of functions video, you know it's going to look something like this. So we factored so that we could find these 2 points, or we used the factored form, and then the multiplied out form helped us find this point. So my second example I've got for you starts with a non-factored form. So the first thing, since I've already got it this way, is I'm just going to picture, all right, well, if x were 0, then I know that y would be 8. So I could go ahead and put that point on my graph. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8. I've got that point. Now I want to find those other points, those zeros or roots. And to do that, I need to figure out how to make this whole thing equal to 0. Well, the best way for me to do it is to split it into those 2 pieces by factoring it, and then making each of those pieces equal to 0. Now this came from my garden video, I factored it for you, and you could see that if this part were a 0, the whole thing would be equal to 0. Or if this piece were equal to 0, the whole thing would be 0. Now instead of writing it all out this time, I just looked at it and said, what number could I put here 2 minus 2 is 0. What number would go here? Well, 4 minus 4 is 0. So I've solved to find those roots. They are 2 and 4. And I can write those out as points. In other words, when x is 2, y is 0. Or when x is 4, y is 0. So I'm going to come back to my graph and graph those. I said when x is 2 or 4, then my y is a 0. That's as much as I know to sketch the graph. And the two different forms, factored and not, helped me find these zeros and this y-intercept. Those were quadratics. Now we're going to look at what happens if you have something bigger, something with a degree bigger than a quadratic function. So here I'm going to show you, I've got an example that has 3 pieces to it. 3 of these little binomials. And the same thing works. I'm just going to say, how could I make this y into a 0? Well, if this piece is a 0, the whole thing's a 0. So negative 3 is a 0. What would make this, all of this into 0? A 1. And this would be a negative 5. These are my roots, or my x-intercepts. And so I'm just going to come onto my graph, and I'm going to graph those 3 roots. So I've got one at negative 3, one at positive 1, and one at negative 5. And there is more I could do to find more information, but for integrated 3, this is really all we look at. And so the rest I'm just going to sketch. I know this had 1, 2, 3 x's here being multiplied together. So this is going to be a cubic function. X times x times x is x cubed. It's going to take on, since it's a cubic function, it's going to take on this shape. And I'm just going to sketch it in there. Like this. There we go. Last example I have for you is, what if it had 4 pieces? Well, here's one with got 4 x's multiplied together. So this is going to be a quartic function. In other words, if I multiplied all this out, the leading term would have an x to the 4th power in it, which means it's going to take on this shape. And now I just need to find those 4 roots. So this one I can really see. I've looked at this before. It's going to be a negative 1. That would be a positive 4. This is going to be a negative 7. But what about this one? What would make this into a 0? A couple ways to think about it. I would just look at it and say, to make that x a 0, I literally make that x a 0. You could also picture this as an x by itself being kind of the same as x plus 0, if you want to see that 0. So now I've got my 4 roots. Now I'm going to sketch this graph. So I've got 0, negative 1, 4, and 7. So I put a point at 0, a point at negative 1, let me make sure I got it right, a point at negative 7, a point at 4, and a point at negative 1, 2, 3, 7. So I know the shape of a quartic function is something like this. And so I'm just going to sketch this in there. Like I said, I could do a lot more, multiply it out, find more values, but for integrated 3, this is what we do. We just sketch it. And that is my guess, my sketch of what this function would look like.